Hey, what do you got? They're actually not, well, leave them here, and I'll take them from there. All right. How have you been?
Good, how are you?
Good, haven't seen you in a while. Holy smokes, that's heavy. All right. You bet. There you go. Thank you, sir. All right. Oh, you're good. Okay. So, guys, again, this is going to go relatively quickly. And so you're going to find, again, as I mentioned, that if you do struggle with this, the reason that I think you're going to struggle is not because of the concept or the math. It's because you don't remember how to write chemical formulas. So I'll help you with that. But, guys, because we are getting into a mathematical unit, it's going to be important to go back and talk about a mathematical concept that we talked about before. Remember significant digits? Okay, so guys, if you don't remember, I'm not going to give you time to write all of this down. What I would encourage you to do is go back and watch the screencast from August 25th, which feels like a lifetime ago, when we went over significant digits. But guys, the thing that you need to remember right now is there are only 4 significant digit rules. But of those significant digit rules, there are only 3 kinds of significant digits, because rule number 4 says nothing else is significant. So guys, can you do it with me? What are the 3 types of significant digits? Non-zeros, final zeros after the decimal, and trap zeros. That's it, guys. No matter how complicated this was for you in the past, that's it. If it's not a 0, it counts. If it's a final 0 after the decimal, it counts. If it's a trap 0, it counts. Nothing else counts. So guys, if that isn't ringing with you, go back and watch the screencast. Then guys, the other thing that you need to keep track of is the rules for rounding significant digits. Remember, when you multiply and divide, you round to the fewest significant digits. When you add and subtract, you round to the fewest decimal places. So guys, again, if you want this in front of you, print the notes. This is on our website. Maybe go back and look at this 25th screencast. But guys, the understanding is for the rest of this unit, you can do this and do it well. So if you need to go back and review, do that on your own. So guys, what are we going to do? Well, we are going to learn to figure out what are called formula masses. This is where you want to take notes. So guys, the first thing that you need to learn is what are compounds made of. Now, ready? Notice the part that's in bold here. This is the you don't need to write this down, but this is the introductory thought. Last unit, these are my notes from last year. Last unit, you learned to write chemical formulas for salts and molecules. What's the problem? That wasn't last unit. Guys, this should have come right after Christmas. This should have been right after you took that test on names and formulas for molecules. Because it wasn't, we're going to go back and remind you how to write formulas. But guys, what you're going to do today is you are going to learn to calculate the masses for compounds. You know how to find the masses for elements. They're on the periodic table. You're going to figure out how to do the masses for compounds. Now start taking notes. So guys, first thing you've got to do is figure out how to break these apart. So if you just write break compounds into their elements, that's what you've got to learn how to do to be successful with this. So guys, I would encourage you to write this first example down. I don't think you're going to need the second example, because my suspicion, well, you may. Nah, I think if you write this first one down, you're going to be good. You're going to pick this up pretty quick. So guys, what I'm going to do is to show you this idea of breaking compounds into elements. Let's take a look at this compound. And again, I'd encourage you to write down at least one example. Can you name it? Maybe we should do this. Guys, grab your ion charts, those yellow papers. Yeah, magnesium phosphate. How do we know that PO4 is phosphate? Because it's on here. Who needs one? Guys, if you either have one and it's out, or you need one, because you need one. Kat, you need one? Robert, you okay? Do you want one? You look like you're digging deep. Here, let's get, oh, good. Nice work. Anyone else? You can need it? Okay. Anyone else? Come on, they're free. You're good? All right. So, guys, magnesium phosphate. The question that you need to figure out is, what is magnesium made out of? So, guys, the logic goes like this. How many different atoms are in magnesium phosphate? How many different atoms are in magnesium phosphate? Do you see the three? What are they? Magnesium, phosphorus, and oxygen. Guys, phosphate as a polyatomic is made of phosphorus and oxygen. So we're going to write those down. This represents magnesium atoms, phosphorus atoms, and oxygen atoms. And if you want to, you can abbreviate and just put Mg, P, and O. So guys, the first thing that we found out then is that magnesium phosphate's made of magnesium, phosphorus, and oxygen. You guys all okay with that? If not, please ask. AP Physics. The funny thing is on the chemistry review book, the picture of the student, she's all happy. The physics student doesn't look as happy. I think that's a life lesson to be learned. Okay, so guys, you good? Okay, but here's the deal. Yeah, it's not enough to just know what's there. You need to also know how many. So guys, how many magnesiums are in magnesium phosphate? 3, right? That's what the 3 tells you. But now, yeah, if any of this is tricky, this is the tricky. So guys, the logic goes like this. How many phosphorus atoms are in this compound? Yeah, so, but if you don't see that it's 2, the idea is there's 1 P in each PO4, but there's 2 PO4s, so that would be 2 phosphoruses. You good? So let's do it. How many oxygens? You get the idea? Is that pretty straightforward? You okay? Okay, so guys, let's do one more just to make sure you're clear. I don't think you need to write it down. We can just talk our way through it. So guys, if you've got something like iron 3 sulfate, and if you look at this and don't understand why this is iron 3 sulfate, do you understand why this is iron 3 sulfate? We'd better talk. So guys, this is not iron 2 sulfate. This is iron 3 sulfate. How do you know? Well, what you've got to do is you've got to break this in half. Sulfate has a charge of -2. That's -6. So this is +6. +6 divided by 2 is 3. So guys, this is actually iron 3 sulfate. So the question is, what is it made of? Well, what are the 3 elements? Iron, sulfur, oxygen, right? So this is made of iron, sulfur, and oxygen. Now guys, how many iron atoms? 2. How many sulfur atoms? Oh yeah, I was going to say 2. It's 3. 3 sulfur atoms. And guys, how many oxygen atoms? An even dozen. You good? You understand the idea? Okay. So guys, I'll bet you can see how to do what we're going to do. Guys, the thing that you're going to learn to do today is figure out the mass of this. So how much does iron 3 sulfate weigh? So to figure out the mass of this, what are you actually going to look up? The mass of iron and sulfur and oxygen. And then what are you going to do? Multiply by what? How many of them there are. And then what are you going to do? Add them up. Guys, that's what we're doing today. What you just described is what is called a formula mass. And guys, you need this in your notes. You are going to learn today to figure out formula masses and molecular masses. So what's the difference? Well, guys, it turns out they're the same. A formula mass and a molecular mass is the same, but they're not interchangeable. If you're finding the mass of a salt, we call that a formula mass. If you're finding the mass of a molecule, we call that a molecular mass. So you can't find the molecular mass of a salt, you can't find the formula mass of a molecule. But the process is the same. So guys, what is a formula or molecular mass? This is the mass of one what we call formula unit for a compound. And guys, when we look these up, when we calculate them, our units are AMUs. How long did we say? 19 minutes? I way overshot it. More like 12. We're almost done. I'm thinking 12. I'm glad you started to watch. Well, the nice thing is this is actually being timed anyway because it's being recorded on my computer for the screencast. So the length of the video is the length of our time. Minus, I'd like to point out, the Amazon delivery. That wasted a good minute. Okay, so guys, here's all you got to be able to do. Ready? Do this with me. So here we've got sodium phosphate. Write it down. You're going, wait a minute, we already did this. I don't need to write this. Write this one down. You'll be glad you did. So guys, sodium phosphate is Na3PO4. Phosphate's minus 3, sodium's plus 1, so you need 3 sodiums and 1 phosphate. So Na3PO4. So let's do the thing you just figured out just in our heads. Guys, what is sodium phosphate made of? Well, how many sodiums? 3. How many phosphorus atoms? Now hold on, is it 1 or is it 4? It's 1 because that 4 does not apply to the phosphorus. And then how many oxygens? 4. So guys, we can write it like this. 3 sodiums, 1 phosphorus, 4 oxygens. Just write it in a column. Okay, so now guys, let's just do what you talked about. How can we now figure out how much sodium phosphate weighs? What do we need to know? The masses of sodium, phosphorus, and oxygen. Grab your periodic tables. So guys, and let me just tell you now. Guys, we're going to go 1 decimal place on these masses. We're going to fix that on Thursday of next week. But for now, we're going to go 1 decimal place. So what is the mass of sodium, element number 11, to 1 decimal place? 23.0. Now, guys, what are we going to do with the 23.0 and the 3? Multiply them together. Each sodium weighs 23. There's 3 of them. That means 3 sodiums weighs 69. Don't forget the units. U, which stands for atomic mass unit, which you may remember is the mass of a proton. Now, guys, what does phosphorus weigh to 1 decimal place? Is it in the 60s? 30s? 30 what? 31. So, guys, 31.0 atomic mass units. And then 31 times 1 is, of course, 31. And then, guys, I know you know where this is going. The last thing we need is the mass of oxygen. Oxygen, I think you've probably memorized by now, weighs 16. 4 times 16 is 64. So guys, now we know the masses of each of the individual atoms times the number of them there are. So how do we now figure out the mass of the entire salt? Add them up. It's 164 atomic mass units. So 1 formula unit of sodium phosphate has a mass of 164 atomic mass units. Guys, that's all we're doing today. Not too bad, right? So what's going to make this hard? And then what can we do to make this easier? Because guys, the thing that makes it hard and the thing that makes it easier are not the same thing. So first of all, let me show you what's going to make this hard. You ready? This is what your homework's going to look like. This is not what your homework looks like. This is what your homework's going to look like. I'd encourage you to write this one with me too. I'm not going to give you the formulas. You have to write them on your own. So guys, we've got chromium 3 sulfate. So what do we need to know in order to write the formula for chromium 3 sulfate? We need to know what chromium is, we need to know what sulfate is, and then we need to know the charges. So guys, chromium is Cr. But if you look at chromium on the periodic table, you'll notice that it's got a bunch of different charges. What do you remember from before Christmas? How do we know which charge to use? The Roman numeral. So guys, the Roman numeral 3 tells us 3. Then guys, we're going to do sulfate. How do you know that sulfate is on the yellow chart and it's not sulfur? because it ends in 8. So you look it up on here, and you find out that sulfate is SO4, and its charge is -2. Now, guys, do you remember how to play the game? +3, -2, where do those meet up first? 6. So how many 3's do we need to make 6? 2. How many 2's make 6? 3. So this would be Cr2SO43. You guys good? Okay. Now, guys, let's do this. We now need to figure out the mass of this compound. Let me show you, Let me show you a way to do this that makes this a whole lot easier. And guys, this is actually the way you're going to be doing this for the rest of the year. So let's just do it right now. So in order to figure out the mass of this, we need to figure out the mass of the parts, right? So we need the mass of chromium, sulfur, and oxygen. So guys, let's do chromium first. Can you find it for me? So 51.99, that's 52.0. But guys, how many chromium atoms are there? 2, right? So 52 each times 2 is what? 104. Guys, write that down right here. 2 chromiums weighs 104. Now, guys, do this. What does sulfur weigh? Find its mass in the periodic table. Is it 32? Is it point something? 0.1. Okay, so guys, sulfur weighs 32.1. But how many of them are there? 3. So 32.1 times 3 is 96.3. So we're going to write that right there. Now, guys, what does oxygen weigh? 16. How many of them are there? Not 4, 12. So that weighs 192. Now, guys, what do we have to do with those numbers? Add them up. 92 plus 96.3 plus 104. And I get 392.3 atomic mass units. You guys buy it? Guys, that's the way you want to represent these. But with that said, guys, I actually, in the homework solutions, have written it all out like this. So when you look at the homework solutions, I've written the entire thing out, so if you're making mistakes, you can find them. But guys, understand, this is not the way that I want you doing these in the homework. I want you doing it like this, because that's the way you're going to do it for the rest of the year. You get the idea? Okay, so guys, look at the homework packet that I put in front of you. What do you have? Like maybe a dozen of these, maybe a few more, 15? Guys, that's your homework for today. You are going to write the formulas for these compounds, then you're going to figure out their masses. What was my time? Come on. 17 minus a minute. Ah, well done. Okay, so guys, we're done. You have, oh wait, it is an assembly scheduled today. Yeah, so guys, we have until 8:57. With that said, Madeline, was it you that I talked with about the assembly? You and I talked about that. Can you do a little plug for the assembly? Guys, let me tee this up. Go to the assembly. This one matters. I don't go to assemblies. I'm going to this assembly. So